Hello student, today we will see the new point, that is the acidity, basicity and neutrality of aqueous solution. Now previous lecture we have seen the atoionization of water, pH scale and a relationship between pH and the pOH. Now these are the 3 points already we have seen in previous lecture. Now today we'll see the 2 points. One is the acidity, basicity and neutrality of aqueous solution and numericals on the pH and the pOH. First, one by one, the neutrality. The neutrality of solution. We know the pure water of any aqueous solution at 298 Kelvin or 25 degrees centigrade, the concentration means hydronium ions, concentration of hydronium ions is equal to the concentration of the hydroxyl ions is equal to the 1 into 10 raised to minus 7 molar. Now there is a value of molar concentration of hydronium or hydrogen, molar concentration of hydroxyl ion equal to 1 into 10 raised to minus 7 molar. Means value of hydronium ion and hydroxyl ions are the same because this is the pure water that contain the same number of hydroxyl and the hydronium or the hydrogen ions. Okay. Now we have to determine, or we knowing the what is the pH of the neutrality of solution. A neutral solution that contain the equal number of hydronium ions and the hydroxyl ions. First, we have to determine the pH of the neutral solution. You know, the pH is nothing but the negative logarithm to the base 10 of the hydronium ions or hydrogen ions. Now see here, pH minus log of molar concentration of hydrogen or the hydronium ion. Now put the value of this hydronium ions. Now here minus log of the 1 into 10 raised to minus 7. That is the value of the molar concentration of hydronium ions. Moles per liter or the mole. Now, if you determine the pH of the hydronium ions, that means minus log of the 1, then a plus or the plus into the minus, this minus, that is plus 7 log of the 10, then is equal to minus log of 1. You know this minus log of 1, characteristic of 1 is 0, minus log of 0, that means 0. Then plus 7 is plus 7, the log of 10, characteristic is the 1 point, log is 0, 0, 0. Therefore, the plus 7 into 1, that is a 7. Means pH of the hydronium ions or the hydrogen ions, molar concentration of hydronium ions, this pH should be the 7. Now this is the neutrality of solution, pH of neutrality of solution. Okay. Now another is the acidity. Now acidity, what is the pH? Acidity of the aqueous solution. Same procedure. The value is, this is the value of acidity. We support the value, the pH equal to the minus log of the H plus ions concentration. That is the formula. But the value of or molar concentration of H plus or hydronium ions is the greater than the molar concentration of the hydroxyl ions. And if you knowing the concentration of hydronium ion is the more, then the concentration should be in between or less than this 10 raised to minus 7, means 10 raised to minus 6, 10 raised to minus 5, 10 raised to minus 4, like this one, means 10 raised to less than 10 raised to minus 7 is the concentration of the hydronium ion if that solution should be the acidic. Therefore, the pH is the less than 7 when the concentration of hydronium ion is greater than the molar concentration of hydroxyl ions. This is for the pH of acidity of aqueous solution. Next one is the pH of basic one. Now here the concentration of hydronium ions, that is a basic one, basic aqueous solution. Now concentration of hydronium ions is the less than the concentration of hydroxyl ions. Then that time the pH should be the greater than these 7. It means that the concentration of hydroxyl ions are greater in that solution, aqueous solution. That's why pH should be the greater than the 7. Now this is about the pH of acidity, basicity and the neutrality. In short, the pH is equal to 7. The solution is known as the neutral one. If the pH is greater than the 7, the solution is the basic. If the pH is the less than 7, then the solution should be the acidic one. Means acidic solution, pH is the less than 7. Basic solution, pH is the greater than 7. And the neutral solution, pH equal to the 7. Now this is about the acidity, basicity and the neutrality of aqueous solution. And that pH or neutrality, basicity and acidity, that solutions are recorded in the according to the pH scale. Now next point, we have to solving one more numerical, that is problems. What is that numerical? First, calculate. Now write on the problem. Calculate pH of 0.01 molar HCl solution. This is the numerical. Calculate the pH of which concentration? 0.1 molar HCl solution. pH and pOH. Calculate the pH and the pOH of 0.1 molar the HCl solution. Now solve this one. You know, the according to that formula for pH equal to negative log of the H plus ions of the hydronium ions. And we have to determine the pH, then we have to determine the pOH, and concentration that is known 0.01. Now here this is a molar concentration and that is given. Put the value here and calculate the pH. Means pH equal to negative logarithm of the hydrogen, means the concentration, molar concentration of the solution. Means with that solution HCl. HCl which dissociate to formation of H and the Cl minus ions. Now this is the concentration of HCl that is given. Therefore, put that concentration in that equation or formula. Now here 0.01 is the concentration of hydrogen 1. Therefore, pH equal to negative log of the 1 into 10 raised to minus 2 or negative log of 1, then according to the rule of apply this logarithm, log a into log b, that is the log a plus log b. Apply this rule. Now log a plus minus this minus, that is plus log of 10 or here 2 log of this 10, then minus log of 1, characteristic 0, and log 1 10 is the 0 0 0. Therefore the minus 0, that is a 0, it becomes a 0, and plus 2 into log 10. Here characteristic of the 10 is the 1, means into 1 point. Log 10 is the 0 0 0 0, means here plus 2 into 1, that is the only plus 2, means pH is the plus 2. This is our first answer. Also, we have to find out the pOH, and there is one relation. Which relation? pH plus pOH equal to 14. Use that formula and calculate the pOH. Now here the pH plus pOH equal to 14. The pH is the 2. We have to find out the pOH. Put the value. Means pH is the 2 plus, here is the plus, pOH equal to 14. There pOH equal to 14 minus 2 and pOH equal to, that is a 2, and that is your the second answer. Now this is for to calculate the pH and the pOH using or knowing the concentration. Okay, now this is about this numerical based on this pH and the pOH. Now this is the acidity, basicity, neutrality of aqueous solution and the numericals on pH and the pOH. Is any difficulty about this numericals or any previous points, then ask anytime or anytime. Okay, students.